Okay, good morning class. So today we're looking at trigonometry problem solving in 2 dimensions and 3 dimensions, 2D and 3D problems. Okay, so last year in grade 11 we've dealt with the sine, cos and area rule. Okay, so this is just an extension of that chapter. Okay, and also the last that you will be learning about trigonometry for the year. Okay, this is the last new thing to you. In this topic, you will solve problems in 2 and 3 dimensions using sine, cosine and area rule you learned in grade 11. You will apply your knowledge of trigonometry, including trigonometric identities and compound angle identities. Alright, so remember, this is the flesh here. If this is the horizontal, which is normally parallel to your x-axis, the angle that opens up, like that, or the angle that goes up, is called the angle of elevation, whilst the angle that goes down is the angle of depression. Okay? So something to note here, that this is your horizontal. Of course, your angle of depression will be equal to the angle of elevation. Why? Because alternate angles are equal. Okay. Also to note at this point is that the trigonometric definitions and triangle rules still apply. The basic definition is sine of A is equal to opposite of hypotenuse, cos is adjacent of hypotenuse, and tan is your opposite of adjacent, which is your circuit totally. Okay? Your Oliver has a hat of apples. Then we are told the sine rule. Remember, the sine rule is going to be A over sine A, B over sine B, and C over sine C, or vice versa. Which is reciprocal, which is sine A over A is equal to sine B over B, which is equal to sine C over C. Your cosine rule, also known as the cos rule. If we're using the cos rule, you must have 2 lengths and an included angle. So we must know AC and angle B to calculate using the cos rule in order to calculate A. Okay, again 2 lengths and included angle, 2 lengths and included angle. For the sine rule, is 2 lengths and non-included angle, or 2 angles and a length. Okay. Or if you have 3 sides here, you're also going to use the sine, the cosine rule to calculate the angle. Alright. And there's your formulae and your manipulation thereof. Okay. And they're just reminding us about the area rule. The area is going to be half AC sine B, again 2 lengths and included angle. So it's going to be half AB sine C, or half CD sine of A. People, these formula are given on the formula sheet. This here, that there, and of course the area rule. The manipulation thereof, you would have to do that yourself. If you want to memorize it, by all means, but we do the substitution and then manipulation. Okay? We don't want to remember too much. That we leave for our history learners. Not so. We don't like remembering things. Okay? I don't have a problem with history. No? The other student asked me now the other day, so what do you have against LO? No problem. I just like maths more. No? Alright. People, the work example, we're looking at the example on page 121. We are told in triangle PQS, R is the midpoint of QS. R is the midpoint. Okay? Which means to say that the length of QR is equal to RS. It's already marked in this diagram. Then we are told that QR is equal to PR equals RS, which is equal to D. So all of this carries a D, or there's a D. Then PS is A, and PQR is theta. The question says prove that A, which is this length here, is equal to twice D, or double D, sine theta. Okay. So where do we start? Where do we start? Firstly, we need to pick up the sum, however. Not so. So we're just going to say, okay, we know that RS is equal to RP, which is equal to QR, which is equal to D. Why is that the case? Given. Okay. So put a little D there and a D. Okay. Then, to pick up A, I think we can use the sine ruler. We've got two lengths and included angle is going to be the cos rule. Not so. So let's see what cos take us. So we need to calculate this angle here. Not so. Now we're going to do that. We know that PRS is equal to angle Q plus angle QPR. Not so. Why? Why is this angle equal to the sum of those two angles? Exterior angle of triangle equal the sum of the two interior opposite. Okay. So, with that said, we need to calculate this angle here. But we know that Q, okay, it's right here given. You don't have to give reasons because this is not Euclidean geometry. Okay, I'm just giving reasons. So later on, you go through the work by mistake, by chance, and then you know where is it coming from. Okay. So QPR is equal to theta. Why? Angles opposite equal sides. Again, you don't have to write this. You just have to write the angle. Unless the question says with reason, which I haven't seen him ask that yet. Okay. So there's theta. So what is the size of this angle? PRS 2 theta. PRS is equal to twice theta. Why? Exterior angle of triangle. And it's triangle PQR. So there's 2 theta. Now what? You can say the cos rule. Not so? So it's simply going to be A squared is equal to D squared plus D squared minus 2 D times D, D squared cos of 2 theta. Not so? Now what can we do? Sorry? Just keep what we need to end off with in focus there. So what can we do now? We can add these, not so? Correct? So it's A squared is equal to 2 D squared minus 2D squared. But remember, this can be written as one of 3. Remember, cos 2 alpha can be written as 2 cos squared alpha minus 1, cos squared alpha minus sine squared alpha, and 1 minus 2 sine squared alpha. Which one of the 3 you think we're going to use? Sorry? The sine. Why the sine? That's what we need to end up with. You guys understand? It's easy, no? So A squared is simply equal to 2D squared minus 2. Oh yeah, got the right thing there. Sorry. This cos is going to be written as 1 minus 2 sine squared theta. So we're going to get rid of the 2D squared there, which is going to give us 2D squared minus 2D squared plus 4D squared sine squared theta. So what can happen now? Doesn't happen now, people. Then cancel. Correct? So A squared is equal to 4 D squared sine squared theta. Now what? Square root. When you introduce square root, plus minus normally not so. But why not in this case? Because a must be positive. We're talking about length here. A has to be greater than 0. So therefore, a is equal to 2d sine theta. Same. Wow, this is. This is worth 5 marks. Okay. So any confusion? No. Alright, so I would like you guys to do from exercise 1. We do number 1, 2, 3 quickly. Okay? Numbers 1, 2, and 3. Exercise 1 is on page 221. Okay? Any confusion? Huh? Now the example. Okay, so what I'm going to do is I'm going to give you a chance quickly. You do number 1 and 2. Draw it along in your books. Then I'll do it on the board. Okay, I'm going to cut it quickly. Alright? Then I'm going to do all the examples or all the sums out of the exercises.